Hey everybody, Daniel here from Basement Tech. Hey, as promised, I'm going to do a couple of videos on the Python code that's part of the zimKnives monitoring project. Very quick reminder of how this fits into the overall project. On the right is the Raspberry Pi, so-called base unit. At the center of it is this Mosquito data broker, which publishes data up to the Node-RED user interface and publishes and gets data from this custom piece of Python code that does two things. It services the hardware that's directly connected, and it implements the higher level alarming functions. Without further ado, let's just jump right into the code. That's down here. There we go. A couple things before we dive in. There are some things which, I've said before, use classes, but when to use classes. I just noticed a few things as I got started on this project that screamed classes right away. Doing object-oriented stuff is not new, but wanting to truly explore Python as a language and a tool, I wanted to definitely explore the object-oriented nature of it. Back in the old days, we would use structures in C and pointers to functions and all of those kinds of things to accomplish similar things, but it's really nice to have the language just obviously support classes. What kinds of things led me to classes? Well, maybe 5 or 6 things. When I started having a bunch of data values that globbed together, when I started having a bunch of functions that I wanted to act on those globbed together data structures, when I started to describe things that were sort of physically related, that really said, hey, you really need to use a class here, Dan. Finally, the code just it became obvious that using a class would make the code way more concise, way more readable, and you'll see that below, particularly in some of the use of looping structures, the looping structures that Python provides. That really made for short work of looping through a whole bunch of similar things and acting on them in similar ways. So what you see on the screen is kind of the lower level of the 3 files that make up the monitoring zimKnives project, and it holds this file, the monitoring parameters.py file, holds 2 classes. One is lower level. It describes a single parameter. And when I say parameter, you certainly would think of in this application temperature, humidity, the gas sensor, but also I use it to represent things like a key switch or a solid state relay. So any of the entities, if you will, that make up the project are described by one of these parameters. I'm going to go into it in a lot more detail, but I did want to just point out one thing that I thought was pretty cool that I learned about Python. In any function, and this is the init function for the parameter class, I guess these are attributes. Sorry, I'm just learning the vocab, but they can come in 2 flavors, and I take a lot of advantage of this, as you'll see down below. First of all, there are required parameters that are positional in nature. All of these have to be in the function call, and they're one after the other, label after value, value after label, etc., etc., etc. But when I get to the ones on the right, I guess they're called labeled parameters. I can't remember the exact terminology, but they're referred to by their label. So once I've taken care of all of the required ones in order, I can include or not include the labeled ones. When I choose not to include one of them, this default value takes effect, and you'll see I take advantage of that down below. I'm going to go through all of these individual pieces of this parameter class, but I'm going to do it down below, where I've put a series, a bunch of instantiations of the parameter class together into what describes the environment that this zimKnives application runs in. So you see that here. I do like the idea that I can be a little free with white space in Python, at least in this case, so that I can lay out this table that describes the environment. You see one after the other instantiations of the parameter class for each of the parameters that I want to describe. Up here you see at the top the labels that describe what each of the columns are, but I'll kind of go through them really quickly one by one. I'm really anxious to get to the ones on the right because I think they're functionally kind of cool. First of all, I need a human readable way to refer to each parameter, and you see that in this column: temperature, humidity, motion input, panic button, key switch, etc. Each one of those parameters has a value, and again, I'm laying in the default values here as well. In some cases, just like space holders, holding space, but in other cases, I take advantage of the default value. The prior value, and as we get further into the code, there were some cases where that was convenient. Each one of these has a unit. I don't know whether you consider true or false to be a unit or unitless, but in cases where there are units, I want to use that mostly for messaging, but in some cases for conversion. When was that data value that acquired? I haven't implemented this much, but in the C language code that's part of the remote unit, it is sending a timestamp. So I will get that populated at some point in the near future. I did talk about the fact that I'm using the Mosquito data broker. Some of these parameters are being published to the broker from the Python code, and in others the Python code subscribes to them, and I wanted to describe that in this direction attribute, and you'll see why that's important and useful when I get to these looping constructs. You can imagine I'm going to loop through all of these and do something clever to each one. When I publish or subscribe to a thing that's held by the broker, it has to have a topic, and that's what this is. It's kind of a free text label that Mosquito uses to keep track of its stuff. I'm going to pause for just a second because now the ones to the right are a little more sophisticated and I think a little bit cooler. Before I get to those cool parameters on the right, one thing I wanted to just note, I keep mentioning this idea of looping through these parameters. I'll show you an example of what that looks like and then talk about how I implemented it. You see here, it's just really cool to be able to do this in Python. You can loop through any list of similar things, and that's just really useful in lots and lots of cases. In this case, I want to, based on knowing the name, the topic, the Mosquito data broker MQTT topic, loop through and just look for that in my list of parameters and return the instance of the parameter class that is related to that topic. So you can see I can just say for parameters in my list of parameters, loop through and look for a topic that's equal to the one I passed in. Now, where does this list come from? I just sort of brute force created a list, literally a list, as part of the environment class. If you guys know of a more clever way to do that, please let me know, but this seems to work out pretty well. Currently, I think I'm putting them all in the list, but there may be a case where I might like to just leave one out of the list. There are other places in the code where I did that for other reasons, but in this case I think I'm looping through all of them. Okay, now to these cool parameters on the right. As I started to code up this application, some of the logic and behavior lent itself to having a few more attributes included in the parameter class. So, for example, some of the hardware elements are, take advantage of the driver's ability to detect edges, not in hardware, but at really low levels. But in other cases, I needed to kind of generate an edge, or in this case I called it an event, based on when the data value changes. So as I loop through and I process these parameters, every couple of seconds, I do that and set that state here in this event attribute. A few of the parameters, the ones coming from the remote unit, are coded in JSON. So I just put a flag here to say when I see a new value advertised from the data broker, do I need to decode that in JSON? So again, pause. That's a couple of logic behavior ones. Now I get to a few of these attributes which talk about how to deal with things that are connected hardware that's directly connected to the Pi's GPIO pins. And this just, I just really like the way this worked out. So I can put in the old days, like a pointer to a function, in this case just the name of a function, and that's the function used to act on a particular pin. I'm going to talk about my configuration class here, but just know that in this case it specifies the pin number of where this particular parameter in quotes, because these things aren't always acquiring, something like a physical value. Sometimes they're just controlling a device, but this column is what's that function. Now I took advantage of another king. I have to admit I'm just trying some things out, but how could I specify a null function? And this lambda, lambda provides a way in Python. Again, the experts already know this, but you can kind of on the fly create function or method code. This is just the simple shorthand for a null function, and I can test on that to see if I need to do anything as I service this particular piece of physical I/O. I'll come back to why this one has that null function and others just have what you might expect, a read or a write on a particular pin, and in what direction are they coming. I added these kind of late in the game, but after I added them I was pretty happy I did. It just makes, again, concise, readable, really nice code as you work your way up the levels of detail. So one or two more things to talk about. Let me talk about this function here. You all know when I'm doing I/O on a Raspberry Pi, I need to initialize the pins as either inputs or outputs or whatever. So I take advantage again of the looping construct here. Let's go through all the ones in the list. In any case where the pin number is greater than 0, I use a default of -1. Look at which pin and whether it's an input and output, and initialize it. Similarly, when I service all of the hardware, every couple seconds in my as my pulse of the application moves on, I look through every one of these physically connected devices and execute its function. Now, I mentioned a few minutes ago that a few of the physically connected things are edge triggered. In other words, the event is created by the driver by noticing a change on the I/O pin. That's the case of this motion detector, and that's why I'm not polling it essentially each time through the loop. I'm just letting the edge detection get the value and set whether an event occurred or not. So in some of these cases, as I say, I'm just playing with the language and playing with the kinds of things I can do, but it worked out really nicely. So I think that's probably enough for this video. Just note that getting the lowest levels of an application organized makes all of the upper level code just so much easier to work with. And sticking to the rules that you establish in a class like this, the rules that you establish for yourself. For example, not directly reading and writing ever to the pins, but letting the class do that work, just makes it an understandable application and a maintainable application, and an extensible application as well. You can imagine if I want to add another thing to this list, I just add it. And if I follow the rules that I set for myself for this class, it's really as simple as just adding another line and maybe a callback function if it's something specific, like maybe I need to add an I2C read or write. I can do that here really easily, concisely, and understandably. Okay, so you can tell I'm pretty excited about this idea of the class at this level. In the next one or two videos, I'll relate how this lowest level organization manifests itself throughout the rest of the application as I move up to the higher levels of alarming functionality. So there you have it. I hope I've convinced you that classes are cool. You probably already knew that, but in this case, remember this when you watch the next video. keep it in the back of your heads for how this data and environment are organized at the lowest level. If you like this kind of detailed discussion about how I did things, give me a thumbs up. If you really like it and want to see the next couple videos, definitely subscribe. And most importantly, if you have comments on not so much the style of the way this was done, but in cases definitely where I'm making mistakes, if there are any of those that you see, or you know, hey Dan, you could have done that looping thing a lot easier this way or that way. I really would appreciate that feedback. Finally, this code and all of this application is available on the Basement-Tech GitHub that I talked about in the last video. So go check it out, play with it, have fun, and I'll talk to you next time.